Okay, we revise back what we have done before. We revise how to calculate capacitance, which is C is equal to Q over V. C is the capacitance, Q is the charge, V is the voltage. Or if you are given the area of the plate or the distance of the plate, you will use the epsilon naught A over D, which epsilon naught is equal to 8.85 times 10 negative 12. This is the constant permittivity of free space, because of the between the plates there's a free space. Area of the plate should be in meter, distance also in meter, so capacitance in farad. So how to calculate parallel, equivalent capacitor, just add all. Equivalent for series, you just put 1 over 1 over. Alright, okay, now we move to example 1. Okay, first read the question. How much charge is on each plate of 4 microcapacitor when it is connected to 12-volt battery? So, how much charge? So here will be Q on each plate. So you have two charge, positive and negative, but same magnitude or same answer or same value. 4 microfarad capacitors, here will be a C. When it's connected to 12 volt, so V. So you have C, V, Q. So what equation you want to use? For question A, C is equal to Q over V. So C you know 4 microfarad. Q you don't know because you have to find the charge. Voltage is 12. So Q is equal to 48 microcoulomb. Easy. 2 marks only. Okay, question B. If this same capacitor is connected to 1.5 volt battery, so it will be V. What is the charge stored? So for question B, still use the same equation. C is equal to Q over V. Battery is 1 over 5. If the same capacitor, so same capacitor is 4 micro, is equal to Q over this one. So Q is equal to 1.5 times 4 micro, we will get 6 microcoulomb. Okay, why the charge reduce? Because we use the minimum battery, which is 1.5 volts, compared to 12 volt battery. Of course the charge higher than this one, right? Okay, now we move to example 2. The potential difference between a pair of, okay, sorry, before that, how much charge on each plate, right? Just now for question A. So you will have positive 48 microcoulomb. The other one is negative 48 microcoulomb. Okay, or you can write as positive negative 48 microcoulomb. Same as this. Positive plus minus 6 microcoulomb. Actually, plus minus is approximately right, but it's okay if you put positive 48 microcoulomb, comma, negative 48 microcoulomb, or you can write like this. Okay. Okay. Next, example 2. The potential difference between a pair of oppositely charged parallel plates is 400 volts if the spacing between the plates is double. What happened to the voltage? What is the new potential difference, or what happened to the voltage, right? If the potential difference between a pair of charged parallel, okay, this one 400 volts, right? And then I double the distance. What happened? Yes, very good. 400 times 2, you will get 800 volts, because the distance are longer, so there will be charge move freely with 800 volts. Okay, now we move to example 3. An air-filled capacitor consists of two parallel plates which an area of 7.6 centimeters squared. So here will be area. So area 7.6 centimeters squared, convert to meter squared, separated by distance of 1.8 millimeters. So here distance is 1.8 millimeter, convert to meter. If a 20 volts potential difference, so this is V, applied to this plate, calculate the capacitance. Okay, so you are given A, D, V, right? So you have to use what equation? You can use both. It depends on the question given, okay? First, calculate the capacitance. If capacitance enough to use the parallel plate capacity equation, which is C is equal to epsilon naught A over D. Just use this one. But first you have to convert this one into meter squared, which is 7.6 divided by 100 squared. 7.6 times 10 negative 4. Here 1.8 millimeter, convert to meter, divide by 1000. So 1.8 times 10 negative 3. So substitute all the value inside here. So you will get capacitance. Okay. For question B, the charge. So just now you already get C. Just use C is equal to Q over V. C is this one, this answer. Q, you have to find Q. V, this one, 20 volts. So you just find Q. Okay. So easy. Okay, how about example 4? Example 4 similar to example 3. A parallel plate capacitor has an area of 5 centimeters squared. So area 5 centimeters squared, convert to meter squared. The plates are separated by 1 millimeter. So distance millimeter convert to meter with air between them. The capacitor stores a charge of 400 picocoulomb. So this one will be charge. Look at the unit. Look at the information given. The charge Q. Just now you are given V. Now you are given Q. What is the potential difference? Now you have to find V. So first you use C is equal to what is the potential difference? Okay. First you use C is equal to epsilon naught A over D. After you get C, you use this equation. C equal to Q over V. You have to find potential difference. How much? Q, this one, 400 pico. Pico is times 10 negative 9. Okay, capacitance. Then you can find capacitance. Okay. Sorry. Pico 1 times 10 negative 12. Sorry. Negative 9 is nano. Okay. In the next video, we'll continue with example 5. So that's all for example 1 to 4. Thank you very much.